Welcome to Narayana online classes. Let's see some problems in friction concept. So first problem, let us see. Yes, see here. In the shown arrangement, if F1 and F2 T be the frictional forces on 2 kg and 3 kg block, tension in the string respectively, then what are their values, he is asking you. So before going to solve this question, first of all, whenever you are solving the friction problems, first find what is the maximum possible friction on 3 kg and what is the maximum possible friction on 2 kg. If they are, let us take that they are trying to move, they are moving, they are in motion. Let us take that they are in motion. Thereafter, we can go for whether they are moving or not, we can conclude by seeing that one. So yes, first maximum frictional forces. What are the maximum frictional forces possible on the blocks? Let us see the maximum frictional forces. Maximum frictional forces. Maximum frictional forces on blocks are. So let here, this is mu1 for our convenience and this is mu2. So here as it is, this is 8 Newton and this is 1 Newton. Let maximum possible here it is F1 and maximum possible is F2 here. So here for my convenience here I am showing this is F1 and here this is I am showing as F2. So F1 maximum is equal to mu1 into N1, normal reaction. So what is that normal reaction? You can see if you take the free body diagram there, see here, this is N1 and here it is, its weight 2g, 2 into gravity, that is 2 into 10, that equal to 20 Newton. So nothing but normal reaction is equal to 20 Newton, you can see. Then F1 maximum will be equal to mu1 0.2 into 0.2 into 20. That equal to 4 Newton. That is F1 maximum possible. Now I can go for what is the possible F2 maximum. Yes, F2 maximum, let us see. F2 maximum, let us see. Second. Yeah. So F2 maximum it is. Second. F2 maximum is equal to. So that is mu2 into N2 it is. If you take the free body of that one, normal reaction N2 upward, M2G downward, M2 that is 3 kg into 10 it is. So that equal to 30. Then F2 maximum is equal to, what is the possible value of F2 maximum? You can see here, F2 maximum is equal to mu2 0.2 into 30 it is. So that is 6 Newton. So that is the 6 Newton. Now if you go back to the question, if you see the diagram once, so here 8 Newton acting. Definitely this 8 Newton will try to move this block this side. And here it is 1 Newton force is acting. So if you see, as this is the dominating force, so that is the dominating force means, now let these two blocks are moving that side, then here friction will act this side. So see here, F1 maximum is 4 Newton. If blocks are moving, let us consider. So here friction is 4 Newton and here the friction just calculated, what is that value? 6. So now you can see here friction is 4 Newton, here friction is 6 Newton. So 6 plus 4, 10, but applied is 8 only. That means both the blocks will not move in this. So both the blocks are not moving means there may be maximum friction values or less than the maximum friction values possible. Let us see. Let me consider first a free body of 3 kg and next I'll go for free body of 2 kg. As blocks are rest because why we are saying maximum friction values are more than the applied forces, we can say as maximum friction, sum of maximum friction values are more as blocks are at rest. Why blocks are at rest means sum of maximum friction values are more means then obviously applied force is less means blocks will not move. Now I want the free body of 3 kg, FBD of 3 kg block, let us see. 3 kg block if you see. So see here, this side 8 Newton applied, this side tension in the string and this side friction F2. So what we can write, T plus F2 is equal to 8. So applied force is 8, maximum friction possible is 6. So that 6 straight away I am taking here. Then T plus 6 is equal to 8. So T is equal to 2 Newton. Tension in the string is equal to 2 Newton. Friction is equal to, friction on 3 kg block is 6 Newton it is. Now I want the FBD of 2 kg block it is. FBD of 2 kg. Now see here 2 kg block if I see, this side tension T and this side 1 Newton force applied. So what is the tension value calculated already? T is equal to 2 Newton calculated and this side 1 Newton. So this side dominating force, then friction will act this side. So then what I can write? 1 plus F1 I should write. 1 second. 1 plus F1 I should write. 1 plus F1. 1 plus F1 is equal to 2. Then friction F1 is equal to 1 Newton. So F1 is 1 Newton, F2 is 6 and tension in the string is equal to 2 Newton. This is the way we can solve the first question it is. Right. That is the first question to you. And next let us see this second question. You can see a car can pull a trailer of twice its mass up a certain slope at maximum speed v equal to 1 meters per second. Without the trailer, the maximum speed of car is 2v he is giving you. The resistance of the motion is proportional to mass and square of speed he is giving you. Resistance force. So first let us see this thing. Solution. Given resistance force R is equal to, what is that? The resistance of the motion is proportional to mass and square of the speed he is telling you. That equal to m into v square, where v is the speed of the body at that instant of time when you are considering. So this is the resistance. And one more thing, when car is pulling the trailer twice its mass up the certain slope means on the inclined plane he is telling you. So here like this, so here is a car and this car is pulling a trolley. This mass is m and this mass is 2m. To pull these two upward, maximum speed with what speed it can pull? With speed v speed it can pull. Then what is the downward force it is? As it is moving upward, downward is 3mg sine theta it is. And this is moving this side with this velocity v. That is the velocity given there in that question. Now, power of the car is equal to power of car. Power of car. Power P is equal to force into velocity. Force into velocity. So that force is equal to, if you see here, what is that force total acting? See here, 3 mg sine theta, mg, 2 mg. Total, how much it is? 3 mg sine theta. And as the block is moving this side, resistance force also downward it is. Resistance force also downward. Then what is the total sum of the force? F is equal to 3 mg sine theta plus resistance. So what is this F? I can write that equal to 3 mg sine theta plus, now what is the total mass? 3m is the total mass to pull upward. So that is 3mv square it is. So now I am substituting that one. Then power is equal to, so 3mg sine theta, 3mg sine theta plus 3mv square into v it is. Let me take this as equation 1 it is. That is, when the car is pulling that trolley, including trolley upward with velocity v. So now, only to pull the car, only to pull the car, only to pull the car. Let me take here the force is F1. So F1, so F1 I can substitute, that F1 is equal to. Now only to pull the car, see here, only car when it is moving, see you can, this is mg sine theta only will act. Mg sine theta, and it is moving upward with the speed v he is telling you, and as it is moving upward, resistance force also upward it is. So then again power is equal to P is equal to F2 into V2 it is. So now F2 is equal to only mg sine theta into R. So F2 will be equal to mg sine theta plus mv square it is. Mg sine theta plus mv square. So now substituting those two values, and V2 will be equal to 2V it is. So then you can see here, now I am substituting that power is equal to mg sine theta plus mv square. mv square, v2 we should substitute mv2 square, because that is moving with velocity v2. So v2 also we need to replace. So now mg sine theta plus mv2 square, nothing but v2 is equal to 2v, 2v whole square means 4 it is. So 4mv square into 2v it is. That is the power. So now this is power and this is also power. Equation 1 and 2, this is, let us consider. So equation 1 and 2, both are the power of the cars only. I am equating those two, then will be 1 will be equal to 2. So how that situation will be? So then 3m taking common, 3m, g sine theta plus v square into v will be equal to, now here m taking common, m into g sine theta plus 4v square into 2v it is. So now here m cancel, v also cancel. So then here one more step, 3g sine theta plus 3v square will be equal to this 2 coming this side, coming inside, 2g sine theta plus 8v square. Given v is equal to 1. Given v is equal to 1, then what is that? This is 8 and this is 3. 3 sending that side, this 2g sine theta bringing this side. So thereby g sine theta is equal to 8 minus 3, it is 5. Then sine theta is equal to 5 by g, that equal to 5 by 10. So sine theta is equal to 1 by 2. So theta is equal to 30 degrees. That is the angle of inclination. Now the thing what he is telling to you is in this question, where now the same truck is coming downward, then what will be the maximum velocity he is asking you. So see here, when it is coming downward, let me show you that one. When it is coming downward, so here downward force is mg sine theta, and resistance force is R, opposition is R, and it is coming downward with velocity v1 he is telling you. Then what is that v1 square value? As it is coming downward, mg sine theta domination, resistance force is opposition. So now resultant force F is equal to mg sine theta minus R it is. So F is equal to MA is equal to mg sine theta minus mv1 square. Now m can be cancelled. So has, what is the maximum velocity? So at maximum velocity, acceleration equal to 0. Acceleration equal to 0 means then v1 square is equal to g sine theta. What is the gravity? 10. What is the sine theta value? 1 by 2. So 1 by 2. Then v1 square will be equal to 5. So this is the answer for you. So like this we can solve. So first power equating, that from that power I am finding what is the angle. Now if it is released, then what is the velocity means? Like this we can solve this question. Yes. Next question we can go for. Yes. Find the frictional force acting on the 6 kg block he is asking you. So find the frictional force on the 6 kg block. If you see here, first I am applying the force 10 Newton this side. When I am applying the force 10 Newton that side, first this block will respond to move that side. So now, friction on 1 kg. Friction on 1 kg is equal to, friction on 1 kg means, let me take this is F1. So F1 is equal to mu1 into N1. So that equal to mu1 means 0.2 mass m1 into gravity it is. So F1 is equal to 0.2 110. So it is 2 Newton it is. It is 2 Newton it is. So F1 is the 2 Newton then. Now I want the free body of 3 kg. Free body of 3 kg. FBD of 3 kg. FBD of 3 kg. Now you can see here, if you see the 3 kg. On first block as 10 Newton is acting this side, friction on this one will be this side. F1. Now if you consider this 3 kg, friction F1 will be this side, both will be this. F1 on upper block is this side, on 3 kg block is this side it is. And here is the friction between 3 kg and 6 kg, F2 it is. So F1 is equal to 2 Newton calculated, then what is F2 maximum? F2 maximum is equal to, F2 maximum is equal to. So here is the normal reaction upward, N2. So that equal to mu2 N2 it is. What is mu2 value? Mu2, 0.2 it is. N2 means this 3 kg block needs to bear this 1 kg block also. Then what is that? 3 plus 1 into gravity it is. So then 3 plus 1 is 4, 3 into 2. So 2 into 4 it is. So that equal to 8 Newton it is. F2 maximum. But if you see here, what is the friction here? 2 Newton between 1 kg and 3 kg. Between 3 kg and 6 kg I am getting as 8 Newton. Now this F1 is acting this side. So friction between 1 and 3 will be the driving force for 3 kg block. Will be the driving force for 3 kg block. I am taking that one. So that driving force is 2 Newton. But here F2 maximum is 8 Newton. That means only 3 kg block won't move. Only 3 kg block alone. Only 3 kg block. Only 3 kg block alone will not move. Will not move. Because as F1 is equal to 2, F2 maximum is equal to 8 Newton. As F1 is equal to 2 Newton, F2 maximum. Because driving is 2 Newton, opposition is 8. So only 3 kg block will not move. Now both. So both 3 kg and 6 kg, both 3 kg and 6 kg can move combinedly. So both 3 kg and 6 kg, because now see here the driving force is friction F1 here, and if I consider 3 and 6 combinedly as single mass, like if I consider, now the friction here it is, as it is rough or smooth surface it is, so smooth surface means friction is 0. So here driving is F1, opposition is 0. Now I am considering that one. So here free body of that one let us consider. So see here. This is 9 kg I am taking, this side F1 and this side opposition is 0 it is, as no opposition is coming. So now, so driving force, resultant force F is equal to F1. So 9 into A is equal to 2. So acceleration is equal to 2 by 9 for, so this A is equal to 2 by 9. A is equal to 2 by 9 is common acceleration of both 6 kg and 3 kg. 6 kg and 3 kg. Now what is the friction on 6 kg he is asking you. So friction on 6 kg is, so friction on 6 kg is, friction on 6 kg is, so here it is F2 and here it is moving this side with an acceleration A. This is 6 kg. Friction on 6 kg is the driving force of 6 kg. So F2 is equal to driving force of 6 kg, which is nothing but friction on 6 kg. Friction on 6 kg. So F2 is equal to 6 into acceleration. 6 into acceleration is equal to, what is the acceleration you got? 2 by 9 we got. 2 by 9. So then it is 3 2s are 3 3s are. So that is 4 by 3 Newton it is. So that is the frictional force on 6 kg block it is. That is about that question. And next one more question. Calculate F. So here it is F, here it is 2F. Then what is that calculate F? That frictional force acting on all blocks is 0. So solution, let us see here. To have frictional force, on all blocks is 0. To have frictional force on all blocks 0 if they move, they must move with same acceleration due to application of forces on individual blocks. On each and every individual block, some forces are acting. Due to this force, this needs to move with some acceleration. So whatever this one is having, same acceleration this force should have. This 3 also must have the same acceleration. The 2 also must have the same acceleration. And that acceleration also, because of the 2 Newton will have some acceleration because of that F only. And this 3 Newton will have the acceleration because of that 6 Newton only. And this 4 will have the same acceleration because of that 2F only. So now, acceleration of 10 Newton. Acceleration of 5 kg, let us see. Acceleration of 5 kg block. 5 kg. So 5 into acceleration is equal to 10 because the applied force on that is 10 Newton it is. So then acceleration will be equal to 2 meters per second square it is. Then what will be the force on 2 kg block? What will be the force on 2 kg? So force on 2 kg equal to force on 2 kg is F is equal to ma. So F is equal to 2 into 2. So F is equal to 4 Newton. F is equal to 4 Newton we can go. If we see here, F is equal to 4 Newton must act here. Here F is equal to 4 means 4 into 2, 8 Newton must act here. So thereby we can get the required answer. That is the solution for that. And next one more question we can say here. A block A of mass 10 kg rests on a second block of B of mass 8 kg. The coefficient of friction are given there, 0.5 and then 0.1 given to you. A horizontal force F is equal to 100 Newton is applied on upper block at t equal to 0. Determine the velocity of block A relative to block B after 0.01 seconds of application of force. The system is initially at rest, he is telling you. Express your answer in centimeters per second, he is telling you. And there the force F is equal to 100 Newton, he is telling you. F is equal to 100 Newton, he is giving you. And the next, after 0.01 seconds, he is telling you. That is, the time also mentioned to you. After 0.01 seconds, what will be the velocity of A relative to B, he is asking you. Yes, let us go for that. First of all, let us find what is the acceleration of each and every block separately. FBD of A. FBD of A. You can see here. So here it is F. Here the friction is F2. Because here he is telling it is mu2, no? So now the friction there it is F2 I am taking. And here this is moving this side with an acceleration A. So then what we can write, F minus F2, resultant force is equal to mass of A, acceleration of A is equal to F minus F2 it is. Mass of A, what is the mass of A? 10 kg it is. 10, acceleration of A is equal to F 100 minus mu mg, mu 0.5, mass 10, gravity 10 it is. So then 10 acceleration of A will be equal to 100 minus 50 it is. So 100 minus 50, 50. Then acceleration of A will be equal to 5 meters per second square it is. That is the acceleration of A. And here you can see the friction between A and B is the opposition for A and is the driving for B. F2 is, now I want FBD of B. FBD of B. So now you can see that one B. So here it is F2 is the driving, F1 is the opposition. And this is B it is. And let this is moving this side with an acceleration B. So now mass of B, acceleration of B is equal to F2 minus F1. So mu2 mass of A, gravity, minus mu1 mass of A, mass of B. It needs to bear both the weights. That's why we should consider that one as well. Mass of B is equal to 8, acceleration of B is equal to, this will be 50, just calculated, mu1 is 0.1, 10 plus 8 into 10, gravity. So 0.1 into 10 is 1 it is. So then 50 minus 18, 8 acceleration of B is equal to 50 minus 18, that is 32 it is. So then acceleration of B is equal to 32 by 8 meters per second square. Now he is asking you what is the velocity of A with respect to B after time 0.01 seconds. Velocity of A with respect to B after 0.01 seconds he is asking. So now velocity of A with respect to B is equal to initial velocity of A with respect to B plus acceleration of A with respect to B into t it is. So then substitution, velocity of A with respect to B 0, acceleration of A with respect to B means acceleration of A minus acceleration of B. What is the acceleration of A we calculated? Acceleration of A is 5 meters per second square. Acceleration of B is equal to 32 by 8. So 5 minus 32 by 8 into 0.01 it is. So then velocity of A with respect to B is equal to 8 5 of 40, 40 minus 32, 8 by 8 into 0.01 meters per second. 8 cancel. Then velocity of A with respect to B is equal to 0.01 into 100 centimeters per second. He is asking the answer in centimeters per second. So then velocity of A with respect to B is equal to 1 centimeter per second. Like this, we can solve this question. As next question, let us see. So here, a 6 kg block is kept on a rough surface with coefficient of friction 0.6. Mu s is 0.6, mu k equal to 0.4 given to you. And thereby a varying force F is equal to 4T is acting. Then Find the acceleration of block at t equal to 5 seconds. At t equal to 5 seconds, he is asking you, what is the acceleration? Find the acceleration of block at t equal to 5 seconds. Oh yes, let us see that one also. Force on force at t equal to 5 seconds. Force at t equal to 5 seconds. F is equal to 5 into 4. So F is equal to 20 Newton it is. F is equal to 20 Newton it is. That is the applied force at t equal to 5 seconds. Now let us find what is the maximum static friction. Whether that maximum static friction is less than this 20 Newton or greater than the 20 Newton, we need to see. So yes, Fs maximum is equal to, maximum static friction is equal to mu s into normal reaction. Mu s is 0.6, normal reaction is mg. So then 0.6 into mass 6 into gravity is 10, 6 6 36 Newton. So if you see, applied force is 20 Newton, but maximum static, that means opposing force is 36 maximum possible, but as the applied force is less than that, so block will not move. As Fs maximum is greater than F applied, block will not move. Block will not move. Block will not move means acceleration of the block is equal to 0. Acceleration is equal to 0, we can write. Yes, that is about it. Acceleration is equal to 0, we can write. Acceleration is equal to 0 it is. So that is about that question. Next question, let us see. A cube of mass m kept on a rough horizontal surface, 2 insects each of mass m moving in the cube with equal accelerations. Moving in the cube with equal accelerations, A0 he is telling you. From D to E, and then H to F, D to E and then H to F, then what is the frictional force on the ground by the cube? Yes, see here. Now I am taking this H to F diagram, that cube, entire cube I am considering. In that H to F one direction and then D to E another direction, we can see. Yes. See here. This is the diagram here. In this, here this side, one insect, and here like this, one more insect it is moving. So then as it is moving like this, friction will be acting there. So if you see that friction value, so here the friction like this, and here also one more friction. So this is, one second let me tell you, this is x-axis, and this is y-axis, and this is z-axis. Now let me resolve that force into components. One second, let me take let me resolve that friction into components. So here the angle is 45 degree. So here friction will act like this, F1. And here friction will act like this because that insect is moving now, that is F2. And now I am resolving that F into components. So F1 cos 45 this side, F1 cos 45 this side, and here upward F1 sin 45, and here F2 again 45 degree here, and this is F2 cos 45 F2 cos 45, and this side F2 sin 45 it is. Now you can see this F2 cos 45 acting like this for that insect, and for the cube it will be acting like this. That means between the surface and that cube, that F2 cos 45 will act backward. And similarly, this F1 cos 45, F2 cos 45 will be acting along Z axis. See here, let me show you that one. Once let me show you like this. So here this is X axis, this is Y axis, and this is Z axis it is. Now here along Y axis, this F1 sin 45 acting, that will be the coming under normal reaction like it is. So this won't exert any frictional force. But when you consider this F2 cos 45, it is when the insect is moving like this, it will exert the friction in backward direction. So that is what I am considering. And when these two along Z axis means when it is moving like this, the friction will be in backward direction here. So that means these two combination plus this one we need to consider here. So total friction is equal to F is equal to F1 F2. F1 cos 45 plus F2 sin 45 into K cap along K, Z direction is, plus F2 cos 45 is. F2 cos 45 I cap it is. What is that F1 and F2 values? F1 is equal to, let me take that insect's mass, something else given there. Cube of mass m is kept on a rough horizontal surface, and two insects each of mass m moving on the cube with equal accelerations a0. From D to E and H to F, the frictional force by the ground on the cube is that F1 and F2 are nothing but ma0. F1 is equal to F2 is equal to ma0 it is. So now substitution ma0. So here ma0, here ma0, 2 ma0 sin 45 cos 45 it is. Sin 45 or cos 45 both will be same. One more step let me write. So 2 ma0 sin 45 1 by root 2 k cap plus F2 again ma0. ma0 cos 45 means 1 by root 2 I cap it is. So now ma0 by root 2 I am taking common. F is equal to ma0 by root 2 into 2k plus I cap it is. Now I want the magnitude. So ma0 by root 2 into root of 2 square plus 1 square it is. So then magnitude of friction is equal to root of 5 by root 2 ma0 it is. Root of 5 by root 2 ma0 it is. Root 5 by root 2 ma0 it is. That is the frictional force value for that question. A chain of mass m and length L kept on a rough surface, mu is the coefficient of friction between the sphere and the chain, F is minimum force required to slide the chain. Then what is that frictional force value required? Yes, see here. What is that F value he is asking? F is the minimum force, then what is that minimum force value? Whether it should be 2 mu mg by pi or mu mg or greater than 2 mu mg by pi or 2 mu mg he is asking you. Yes, let us see that one here. Solution. If you see this entire diagram, the chain is here like this it is. The chain is here like this. If you see that one, friction is equal to mu into normal reaction we need to consider. See here. Let me take the diagram. So here is the chain like this. Here is the chain like this. And now this is the normal. And here I am considering a small portion where this is making an angle theta. And here this mass is dm. Okay? And now this mass is dm into gravity it is. Dm into gravity. Now I am resolving them into components. This side it is dm into gravity, and this side it is dm into gravity into sine theta its side, because this is theta now, this will be obviously theta it is. And here it is dmg cos theta it is. And here is the normal reaction it is. Is the normal reaction it is. And this small portion mass is dm and its length is dx for our convenience. Dx for our convenience. And now I want the normal reaction value. So normal reaction n is equal to dm into g cos theta it is. Dm into g cos theta. See here, if you consider this portion, this is theta. If I go to this somewhere here, theta is increasing. If I come here, theta is decreasing. That means the theta value is not constant. Theta is continuously varying. When theta is varying, normal reaction is varying. When normal reaction is varying, frictional force also varies. Now I need to find the total frictional force on that by integrating process. Yes, let us see that one. Frictional force on that small part element is friction on small part dF is equal to mu into n it is. So dF is equal to mu into n means dm g cos theta. So now dm is the length, dm is the mass of that small portion it is. Dm is the mass of this small portion and its length is x. He's telling you that mass is m and length is L. So for the total length L, mass is m. For dx length, what will be the mass? I'm considering that one here. So for L length, mass is capital M it is. For dx length, the mass will be how much? That is dm. That is what I have taken. So then dm will be equal to m by L into dx. And then dx will be equal to r into d theta, where r is the radius of that one. And come on, let me substitute this dm is equal to m by L into r into d theta it is. And now this dm value I am substituting there. So df will be equal to mu m by L r g r into cos theta d theta it is. Now I want the total friction. Total friction here. So F is equal to integration of mu m g r by L cos theta d theta it is. So minus pi by 2 to plus pi by 2 it is. One more step, let me write. Friction F is equal to mu mg r by L, mu mg r by L into integration of cos theta. Integration of cos theta is sin theta minus pi by 2 to plus pi by 2 it is. So F is equal to mu mg r by length is equal to pi r ra. You can see the length of the chain. 1 second, let me go back. So it is half of the circle ra. So half of the circle means obviously pi r length it is. So I'm considering that one here. So length is equal to pi r. then sine pi by 2 1 minus of sine of minus pi by 2 minus 1 it is. So then F will be equal to 2 mu mg by pi. This is the friction. And now what is the force required to move the block? When you are pulling this one, here we need to overcome the friction and we need to maintain some tension in that string as well. So we need to maintain some tension in the string. So total force to pull chain F is equal to 2 mu mg by pi, 2 mu mg by pi plus tension. Plus some tension also we need to overcome. We need to give some tension in that. So F is greater than, some tension also coming there, no? So obviously greater than 2 mu mg by pi. So this is the answer for that. And next one more question it is. See there, the coefficient of friction between the block A and mass m and block B of mass 2m is mu. Between A and B, coefficient of friction is mu given there. There is no friction between block B and the inclined plane. Between B and inclined plane is no friction, he is telling you. So if the system of blocks A and B are released from rest and there is no slipping between A and B, then which of the following option is possible? So right. Let us see here, solution. As no friction here, so that means both blocks move combinedly along incline with acceleration g sine theta it is. With acceleration g sine theta it is. So now see here, acceleration g sine theta it is. Now take the diagram here. So here is B block and here it is block A. So here it is g sine theta, like this both are moving. Let it be A. Both are moving like this. So that means for that block A, for block A, if I take, this is A. So now for block A, if I take, so here it's weight downward, mg, and here it is having normal reaction from B, n, and here this is moving like this with an acceleration A, and this is theta it is. This is theta. So that is theta means obviously this side also, this side it is, this is theta and this is A cos theta and this is A sin theta and here the friction, because friction there between A and B. Between A and B friction is there, so that's why as this A cos theta, this block is trying to move this side, friction should oppose that one. So now along vertical, if you see, along vertical, mg minus n is equal to ma sin theta. ma sin theta. So n is equal to mg minus m. A is equal to what? G sin theta. G sin square theta it is. So n is equal to mg into 1 minus sine square theta. So n is equal to mg into cos square theta it is. That is along vertical it is. Next along horizontal. Along horizontal if you see. Along horizontal. Along horizontal. You can see that one. Along horizontal means friction is equal to along horizontal to be in equilibrium. To be in equilibrium, friction should be greater than or equal to ma cos theta. So mu into normal reaction greater than or equal to m. A is equal to g sin theta. G sin theta cos theta. Mu normal reaction mg cos square theta. Mg cos square theta greater than or equal to mg sin theta cos theta it is. So cos square theta, cos can be cancelled, mg also gone, then cos sending that side. So then mu will be greater than or equal to tan theta. So theta is less than or equal to tan inverse of mu it is. So theta is less than or equal to tan inverse of mu. This is the relation for that question to you. Yes, thank you so much. Next question we'll see that. Yes, this is another question. A long chain of mass m, length L, is being pulled with constant velocity on a rough inclined plane with coefficient of friction mu. At what rate of fractional force the chain is increasing? At what rate frictional force is increasing, he is asking you. For example, let a small length dx length is moved this side. Let a small length x is moved onto 37-degree incline from 60-degree incline. Then change in normal reaction. Change in normal reaction. Nothing but here x is increasing here, x is decreasing here, there. So then what will be the frictional force? Frictional force is equal to frictional force is equal to F is equal to mu into n1. Mu into n1 plus n2 it is. That means normal reaction on this and normal reaction on this. So yes, as x length we are discussing about, F is equal to mu into normal reaction means x length came to here. That means what is the mass per unit length I am considering? Nothing but some m1 on this and m2 on that. So m1 into what is the change in frictional force he is asking? m1 g cos 37. m1g cos 37 minus m2g cos 60. Cos 60 it is. So m1 is equal to m by L into x. m2 also m by L into x it is. Now I am substituting that one. See there. So friction is equal to mu into m by L into x into g. It is cos 37 minus cos of 60 degree it is. So then friction will be equal to mu m by L into x into gravity. Cos 37 value 4 by 5. Cos 60 value 1 by 2 it is. Cos 60 value 1 by 2 it is. So then by substituting we will be getting, what is that we are getting? 5 to 10 it is. So mu mg by L into x, 10 LCM taking. So this will be to 8 minus 5 it is. So that is F is equal to 3 mu mg by 10 L into x. So rate of change of friction. Rate of change of friction. Rate of change of friction it is. So dF by dt is equal to 3 mu mg by 10L dx by dt it is. So then 3 mu mg by 10L into V. So this is that one answer for you. As next question, let us see. So a block A is placed over a long rough plank B of same mass as shown below. The plank is placed over a smooth horizontal surface at time t equal to 0. Initially, this is the smooth surface, here it is the rough surface he is telling. Block A is given a velocity v0, horizontal direction, and let v1 and v2 be the velocities of the bodies A and B at time t. Then choose the correct graph from the given information. Let us see here, FBD of A. FBD of A. You can see here, this side V0 velocity given, so friction this side it is. And if you see here, FBD of B, this is a plank. So here, as friction is acting this side, on B, friction will be acting this side. Due to that, it will start moving this side. U is equal to 0, of course, initial velocity, and slowly its velocity increases. So V1 is equal to V0 minus A into T, A1 into T. So here V2 it is. V2 is equal to U, 0 plus A2 into T. Now you can see, as time being, velocity of A is decreasing, as time being, velocity of B is increasing. After some time, both blocks will be having same velocity. V1 is equal to V2. Then how the graph will be? Combined motion if I consider. So here it is V and this is T. Initially, block A is having velocity V0. Its velocity is slowly decreasing. Its velocity slowly decreases. And B is having 0 velocity initially. Its velocity slowly increases. After some time, both the blocks are having the same velocity. With that same velocity, both blocks will move, continue their motion. So this is the graph between velocity and time for both the blocks it is. So that is the answer for you. And next, see here, in the situation shown in the figure, friction coefficient between M and horizontal surface is mu. So the diagram is like this, it is. Diagram is like this, it is. Here a force F is acting like this. And here this is the force, this is theta given to you. This is the force F given, that is the diagram. Okay, where theta is the angle with the vertical he is telling you. The correct statements in this question are, Now, let me resolve this into components here. Block of mass m is mentioned here. So, here, let me resolve that force into components. Let me resolve that force into components. So, this side it is, and like this. So, here it is F cos theta like this, and here it is F sin theta, and here it is mg, and here it is normal reaction. As F sin theta is trying to pull this one, now the friction will be this side it is. And now let me find first what is the normal reaction there, and then I can go for friction there. So normal reaction. For that what we can write? N is equal to mg plus mg plus f cos theta it is. mg plus f cos theta. Now I want the friction also. Friction is equal to mu. F is equal to mu into normal reaction. F is equal to mu into mg plus f cos theta it is. So that is friction for you. Now to just move the block, f sin theta. F sin theta must be greater than or equal to friction. To just move the block, f sin theta must be greater than or equal to friction. So f sin theta is greater than or equal to mu mg plus f cos theta it is. And see here, let us bring this thing this side. So then f into sin theta minus mu cos theta. Sin theta minus mu cos theta is equal to, minimum discussion let us see. So that equal to mu mg it is. So then f will be equal to mu mg by sin theta minus mu cos theta. Sin theta minus mu cos theta it is. So now to have, if the sin theta minus mu cos theta is equal to 0, that means something by 0 means it will be infinity. Infinity force application is impossible. So that means what? Sin theta minus mu cos theta must be greater than 0. It should not be 0. It should never 0, because applying the force infinity is not possible. So then mu cos theta, one second, sin theta is greater than mu cos theta, then tan theta is greater than mu, motion possible. Less than, he is telling motion is not possible. So like this, we can check it out. As next question we can see. So here, two small blocks, mass m is equal to 2 kg, each of kept on a wedge 12 kg it is. Then there is no coefficient of friction between the wedge and the ground. Between the wedge and ground, no coefficient of friction. Next, friction between wedge and ground is 0.3. The frictional force by ground on the wedge is. So now see here, from this block on this normal reaction N1 on wedge, and from this block normal reaction on this is N2. Okay, that equal to what? mg cos 30 it is. And here it is equal to what? mg cos 60. And now, what are the forces on wedge? Forces on wedge. Forces on wedge. You can see there, we take the diagram clearly, free body diagram of that one. So here it is N1 and here it is N2. And now let me resolve those normal reactions into components. Normal reactions into components. So here this is 30 degree given to you, and here this is 60 degree given to you. Now n1 cos 60, n1 sin 60 it is. And here it is n2 sin 30 it is. Okay, and its weight is mg downward, and from the ground normal reaction n3 upward. So here n1 cos 60 it is, n1 cos 60, here it is n2 cos 30 it is. Now along vertical it won't move, but along horizontal we need to see this n2 sin 30 and n1 cos sin 60, whether these two, what is the resultant force we need to see. If the resultant force is there, thereby we can get the required answer. So resultant force on wedge is F is equal to n1 sin 60 minus n2 sin 30 it is. So that is mg cos 60 sin 60 minus mg cos 30 sin 30 it is. So thereby mg 1 by 2 root 3 by 2 minus mg root 3 by 2 into 1 by 2 it is. So thereby resultant force is 0. So no friction acts on wedge. No friction acts on wedge it is. Next, see here. Consider the diagram and match the following questions. See here, when you are applying the force like this, so here friction, when you are trying to apply the force like this block will start moving this side. So that means here friction is 2m plus m, 3mg, mu into 3mg it is. And here this is mu mg it is. Mu mg it is. And here it is tension T. And here it is tension T. So now F is equal to solution. F is equal to mu into 3mg plus mu mg plus T is. So to just move blocks it is, to just start moving. So F is equal to what I can write? 4 mu mg plus T it is. And next I want FBD of M. For M, you can see it because I want to find the tension T there. So here is the tension T because this is tension T. So here also tension T, here also tension T it is. So tension T this side, now friction will be this side. So that is mu mg it is. So from that what we can write? T is equal to mu mg. Let me take this is equation 1 and this is equation 2 it is. So from here what we can write? From 1 and 2, F is equal to 4 mu mg plus T. So that equal to 4 mu mg plus mu mg, that equal to 5 mu mg. This is the force required. This is the force required to just move blocks. This is the force required, 5 mu mg. That is a minimum force required to move the blocks. 1 second. So to move these blocks, 5 mu mg is required. Now, what is the force applied? 2.8 mu mg. What is there? Consider the diagram and match the following. So, what he is asking, what are the frictional forces? F is equal to 2.8 mu mg applied, then the friction on upper block is. If the applied force is very high, then here the friction is 3 mu mg. But applied is how much? 2.8 mu mg only. When you are applying 2.8 mu mg, then the friction on upper block, that means bottom block is not moving, means upper block won't move. Then for option A, as block will not move, so the answer is Q it is. Because friction won't, because that M will not started moving, so then friction will be 0 on that. And next, for B, if you see, if F is equal to 4 mu mg, friction on lower block he is asking you. So here 4 mu mg I applied, first bottom contact will start moving. So here it is 3 mu mg, and out of 4 mu mg, already 3 mu mg is over. Then how much is remain? Mu mg, and here mu mg. So that means both will be sharing 0.5. So 3 plus 0.5. 3 plus 0.5 mu mg. So that is 3.5 mu mg it is. 3.5 mu mg. So for that B is T it is. And next, if I apply F is equal to 5 mu mg, friction on upper block, it is mu mg, just now calculated. Friction on upper block is equal to mu mg, just now I have seen. Friction on upper block is equal to mu mg. If it is 5 mu mg applied, for C, it is P. And for D, if you see, what is he telling you? 4.8 mu mg. Out of 4.8, 3 mu mg at the bottom, fixed to that one. And what is remaining? 1.8. So 1.8 will be shared by this one plus this one. So 1.8 by 2, 0.9. So then what is that? For D it is, R is the answer. So like this, we can solve that one. Yes, next question we can see. If blocks M1 and M2 are placed together on an inclined plane, then the coefficient of friction between M1 and the plane is always 0. So here mu is 0 for this, here mu is 0, and here mu is 0.3 given. A list 2 of expressions for block M2 is given. Match the correct expression for the friction in list of 2 with the angles. Near some angles are given, then what will be the friction there he is asking you. Yes, first let me find at what angle both the blocks will start moving. Angle of repose let us find first. So, at what angle both the blocks will start moving. So, see here, this is M1 and this is M2. So, here this is M1 plus M2 G sine theta this side. And here friction, only at the bottom block we are experiencing the friction. So that friction is equal to, F is equal to mu M2 G cos theta. So at angle of repose, blocks just start moving. So that means mu M2G cos theta is equal to M1 plus M2 into G sin theta it is. M1 plus M2 into G sin theta. What is M1 and M2 values given there? Where M1 is 1 kg, M2 is 2 kg given to you. And mu is equal to 0.3 given to you. Yes, let me substitute that one. 0.3 to 10 cos theta is equal to 3 10 sin theta it is. So then 10 cancel. Then sin theta by cos theta. Tan theta is equal to 0.6 by 3. Tan theta is equal to 0.2. For what value this will be? So 0.2 is equal to 11.5 degree it is. So theta is equal to 11.5 degree. If theta is, if the angle of inclination is less than 0.5, if theta is less than 11.5, friction is m1 plus m2 g sin theta. If theta is greater than 11.5, friction is mu m to g cos theta it is. So by taking the values, you can get the required answer. So that is about that question. Yes, thank you so much. That's all about this.